This playlist collects together and organizes the modules for the first of 2 lectures on statistics. During the course of these 2 lectures, we'll cover 2 major areas of statistics, what's sometimes called inferential statistics and what's sometimes called descriptive statistics. We'll start just by talking about what statistics is and why it is useful and important for you to become statistically literate. Then we'll turn our attention to an area of statistics that's often called inferential statistics. We'll look at the relationship between samples and populations, both inferences that go from a population with a particular frequency to calculating the probability of getting a sample of a particular size with a particular frequency given that population, and then at the inverse of that inference, or what's sometimes called inverse inference, where we go from a sample with a particular frequency to make an inference about the population. And then we'll focus in on what's called the margin of error and its significance and relationship. After we're done with that first lecture on inferential statistics, we'll turn our attention to descriptive statistics, that area of statistics that focuses on describing data, presenting data, analyzing data, seeing trends in data, understanding that data. The first thing that we'll look at are measures of central tendency or average. Then we'll turn our attention to measures of dispersion, or how the data is spread out, or the shape of the data. Talk about graphical data presentation and the potential pitfalls or misrepresentation of data through graphical means. And we'll end with reasoning with percentages, specifically with cautionary notes about reasoning with percentages. So let's turn our attention to this first lecture. As I said, we'll start off by talking about what statistics is and why it's important for you to understand and be literate in statistics. Turning our attention to inferential statistics, we'll start by looking at how mathematicians and statisticians realized that if you have a population with a particular frequency, you can use that basic classical probability theory that we learned in the probability theory lecture to calculate the probability of drawing a sample from that population of a particular size with a particular frequency. What we'll see is that when we start doing that in a systematic way, the frequencies of those samples will arrange themselves around the population frequency, where the most probable sample frequency is the one that's the same as the population frequency. And as you move in either direction, greater or lesser frequency, you start to get this bell-shaped curve that is the normal distribution, so that the sample frequencies and their likelihoods will be normally distributed around the population frequency. Then we'll turn our attention to inverse inference, as it's sometimes called, or inferences that go from a sample to the population. And we'll look at the central limit theorem, the theorem that underlies the mathematicians and statisticians' understanding of that relationship that goes from samples to populations, and how that relationship mirrors the relationship that goes from populations to samples in inferences. We won't discuss the central limit theorem in any great detail, and we won't be using any very sophisticated mathematics, but we'll get an understanding of what it is and how it works, I hope. Finally, as we'll see, when we make inferences from population frequencies to sample frequencies, we can come up with a normal distribution. Adding the values within a range in that normal distribution, we can get a standard deviation. That standard deviation from our samples can provide us with an estimate of the margin of error. That is, if we have a sample frequency What is the range of possible values for the population frequency that falls within a specified range of values such that 95% of the time the population frequency will fall within the sample frequency plus or minus the margin of error. So let's get started. What is statistics? What are the two areas we're going to look at? And why is it so important for you to understand statistics? Well, we can understand statistics as having two general emphases. On the one hand, we can think about descriptive statistics. That part of statistics that focuses on describing data, presenting data, analyzing data so that you can better understand it, see trends and relationships within it. On the other hand, we can think about inferential statistics. That part of statistics that focuses on sampling populations and generating statistical hypotheses from those samples. I like to start the lecture on statistics with inferential statistics. I think it's helpful in understanding descriptive statistics, and it's also important for being statistically literate, to understand just in the very basic sketch how it is that statistics actually works. So in our probability lecture, you might have walked away saying, hey, I think probability is great. I can now calculate the probability of complex events using my rules from the probability of their simple constitutive events. But then you might have reflected on those three interpretations that we use pragmatically to estimate the likelihood of those simple events. And you might say to yourself, well, those are just estimates. I don't really even know how good they are sometimes, particularly when I can't use the classical interpretation. How do I know the likelihood of something in the real world if it doesn't satisfy the constraints of the classical interpretation? That is, the principle of indifference and the ability to determine all the possible outcomes and all the favorable outcomes. And when you think about it, none of the definitions helps you understand probability in a way that allows you to know real-world likelihoods without significant effort. And you might have been frustrated by that, but you shouldn't be. Because what we'll see is that with a little probability theory, we can actually come to understand how we can estimate real-world likelihood with great confidence. And this is the real miracle of statistics. This is the reason why statistics touches you in every aspect of your life, in every day of your life, because it is an incredibly powerful inductive inference strategy, a strategy that's made all the more powerful, not just because we can make those inferences, but because we can calculate how much epistemic risk we're incurring in making those inferences, and we can even manipulate the amount of risk that we're incurring when we make particular inferences. We'll pick that up in the next lecture module.